If you want to learn how to write C for Raspberry Pi's new microcontroller, the Pico, stick around. We're doing that next on Low Level Learning. So the way we're going to start is we are going to go to Google and we're going to search for Raspberry Pi Pico. And that's going to get us to the Getting Started site. So there are a lot of really good resources here that Raspberry Pi has put out on how to get started with the Raspberry Pi Pico. Specifically, we're going to go to the C++ area, go way to the bottom, and then we're going to go to the Raspberry Pi Pico C++ SDK. That'll bring us to what I would argue is one of the most well-documented APIs for an MCU I've ever seen. This data sheet should be used whenever you're programming the Raspberry Pi. They fully document almost every API that the Raspberry Pi Pico has. So if you need to learn something new or want to play with a new feature for the device, you need to go here. So once we have this document open, we're kind of reading through it. We're going to be playing with the hardware GPIO functionality of the board. You don't have to really read too much of the documentation to understand how this part works. It's just good to know that it's here. So once you've kind of perused this documentation a little bit, you're going to go to GitHub and go to this link. I'll put this link in the description in the video right there. You're going to clone this link. So this link is the code required by the developer to interface with the board. Without this middle layer of code between us and the Raspberry Pi, we wouldn't know how to do a lot of things that the board is capable of doing. The Raspberry Pi produces this code to enable us to do it. So if we ls-tac-l on Pico SDK, we should have gotten this nice folder of a bunch of different libraries and CMake files and all that other good stuff. So now that we have our SDK in a place that we can use it, which is just in the home directory right here, we need to make a folder that is going to contain our project. So for me, I made this folder called custom, right? So you can name it whatever you want. You can name it potato, cat, doesn't matter. Just make a folder that is where your code is going to live. So then what you need to do is into your project folder, you need to copy from the Pico SDK external this CMake file. You should put it in your folder, right? So now if we read the contents of my folder, we have this CMake file. The CMake file that we get from Raspberry Pi is actually a part of the CMake build system. So I'm not going to get too deep into this, but CMake is this really powerful build system that is platform independent that allows developers to control how their code is compiled, built, and tested. So by making the Raspberry Pi Pico build through CMake, you can actually build projects for it on Windows, Linux, or otherwise. Pretty cool. So now that we have this file here, we need to make this new file that we're going to write. It's called cmakelist.txt. And I have mine open here. So go ahead, pause the video, and copy this down. Basically, what this does is it sets up our build environment to import that file that we got from Raspberry Pi to set the name of our project and a couple programming standards. It initializes the SDK, which means that it sets up the build environment to use that SDK for us. We then say that we're going to produce an executable called blink, which is the name of the tutorial, from the blink.c file. We're also going to link the Pico standard library, which we need to do Pico things, right? Kind of like the C standard library in C. We're going to link that library into our blink executable. And then finally, we're going to do this part called Pico add extra outputs blink. So if you've seen other tutorials, when you use a Raspberry Pi Pico, you produce a UF2 file. The way you produce that file is by adding this to your CMakes list. So go ahead, copy this down, and once you have that file written out to cmakeslist.txt, we'll keep going. Okay, so now we're going to actually do some programming, right? So here we have blink.c, which is the actual code that is going to get ran on the Raspberry Pi Pico. So pretty straightforward here. This is pretty similar to how the Arduino works when it comes to GPIO. So the first line here, we're going to include pico/standardlib. Note that these are in quotes and not in hard braces. That's because we're actually using the Pico SDK, and the way that CMake involves include files, we were allowed to do quotes like this. We're going to do 3 pound defines. The first is GPIO on, which is just 1, GPIO off, which is 0, and then we're going to define the LED pin on the Raspberry Pi, which, as we saw from our schematic here, it's pin 25, right? And again, this picture is really powerful if you want to do other stuff with the board, but for this tutorial, just GP25 is all you need to know, so pin 25. All right, so we have pin 25, and then just like any other C function, we initialize our main function. We need to initialize GPIO on a pin, and in this case, we're going to initialize it on the LED pin, and then GPIO set direction. So just like in the Arduino tutorial I've done, where you have to set the pin as an output or an input pin, we have to do the same thing. So LED pin becomes a GPIO out pin, because we want to put voltage and source current from that pin as opposed to sync current into that pin. And then while true, so we're going to serve this code forever, put something onto the GPIO line on pin 25, turn it on, done. Then we're going to sleep for 2000 milliseconds or 2 seconds. And then we're going to do a GPIO put. We're going to, on the LED pin, turn it off, and then sleep for 2 seconds. And then we're going to serve that forever. So normally when you're doing this, you would either put this code into like the Arduino IDE, or you would run GCC on it. Now that we're using CMake, it's a little more complicated. It's not too bad though. You need to first make a build directory, and then we're going to go into that build directory. And then first of all, if you don't have CMake installed, you need to make sure you go out and do that. And the way you do that is by doing sudo snap install inmake. And for me, I already have it installed, but if you didn't, it would install it for you. After we've installed CMake, we need to write export pico SDK path equals the path to your pico SDK. So for me, it's this directory. That exports a global variable to the environment that tells CMake where to look for the pico SDK that Raspberry Pi provided. Now that we have that taken care of, to create our build chain, we need to do CMake ... And what that does is it tells CMake to build the program build structure that's listed in our CMake list.txt. Once we've done that, we can run CMake ... What that tells CMake to do is to look in the folder above it for this file, the CMake list.txt, and build the build chain for this program. We'll run that here. Great, and now that that's built, we can look in this folder again, and before we had nothing in this folder, and now we have a make file. And now, just like we're used to doing normally, we can run make on this folder, and the build chain will produce all of the code in Pico binary format. And now that all that is done, we have our blink.uf2 file, which is the one that we can actually put onto the Raspberry Pi Pico. And now that we have that file, I can copy that file to media user Raspberry Pi 2. Doing that, if you heard the little doot on my computer, it actually unplugged the Raspberry Pi for me, and it booted back up. Now it's running my program, and I'll put a picture of the Raspberry Pi right there. Anyway, so I hope that made sense to you guys. The build chain for Raspberry Pi Pico is a little more complicated than things like Arduino and so on, but CMake is really powerful, and I cannot emphasize enough how good this documentation is. You can take this tutorial and this document and do a lot of really powerful things with the Raspberry Pi Pico. Anyway, guys, I hope you learned something today. If you did, please drop a like, hit subscribe, and I'll see you guys in the next tutorial in probably about a week from now. Keep on learning and have a good night. Bye-bye.